quadratic formula. So we are on to section 7. On to section 7 in your books. Quadratic formula, page 213. So I will say I use quadratic formula. That is my go-to. If I cannot very quickly factor it, I use quadratic formula for everything. There is no thinking about it. You really just need to know the formula, and then you can just plug it in, all right? And so if you have something that either is really difficult to factor or cannot be factored, quadratic formula. Completing the square is something that you're going to use probably in a way to get something out of a root, right? And so there are ways to manipulate something in a root so that you force a perfect square, and then you can get it out of a root. But most of the time people will either use factoring or quadratic formula. Those are the two most common methods. If it's really simple factoring, factor it, be done. If it's not really simple factoring and you're stuck on the factoring, then go to quadratic formula, because this one will always work. It is derived by completing the square. So when you see this crazy quadratic formula, it comes from the completing the square method. All they've done is they have put the b over 2a, and they've done all this crazy stuff to manipulate it, and then they've come up with this quadratic formula. But it stems from completing the square. That's where this quadratic formula comes from. Quadratic formula is listed at the top of page 214. You do need to memorize this. You do need to have this memorized. There will be ones that you must use the quadratic formula for. It is negative b plus or minus the square root of b squared minus 4ac over 2a. All right? And so you need to memorize it. All right, so let's look at using the quadratic formula. Using it, just like with factoring, it must be equal to 0. So you'll notice in completing the square, it wasn't equal to 0. It doesn't matter. You actually just want the x squared and the x by itself. But for quadratic formula and for factoring, the first step is that you have to have it equal to 0. It also needs to be in standard form, okay? Which means I need to move this 5x over by subtracting it. It will not combine with anything over here. So we have x squared minus 5x plus 4 equals 0. It has to be in this format. If it is not in this format, you will get your a, b, and c messed up, okay? So the a is the number in front of the x squared. The b, including the negative, is the number in front of the x. And the c is the constant. And that means if that is a negative, then you use a negative. If it's minus 4, you would say negative 4. All right, so you have to use the positives and negatives that are in front of the a, b's, and c's when you plug this in. All right, so then we're going to plug it in. Negative b. B is negative 5. So we say negative 5. That's why you have to do that. Plus or minus the square root of b squared minus 4 times a times c. All of that is over 2 times a. So quadratic formula, you just memorize and plug in your a, b, and c. That is what x is going to equal. So your quadratic formula does not have any x's in it. The quadratic formula is what x equals, okay? It is just your coefficients and your constants that you are using. Once you've plugged it in, you are just doing order of operations, okay? Order of operations says I do my exponents first. Here's the thing, grouping, that radical is a grouping, okay? So I'm doing my grouping first, but within that grouping, I'm doing that exponents, okay? So this is my grouping, my radical is my grouping. Within the radical, I have to do the exponent, then I'm gonna do this multiplication, then I'm gonna do that subtraction. Once you've done that, do your order of operations. Negative, that's going to be a positive 5. Negative 5, anytime you square any number, it is positive. I have 4 times 1 times 4, so that's minus 16. All right. And then all over 2 times 1 is 2. All right. Then I am going to do under the root. So I have 5 plus or minus 25 minus 16 is 9, all over 2. This actually works out. Hopefully, you could see that that guy's factorable. Negative 1 and negative 4 would have been factored there. This is actually one I would not use the quadratic formula for, but they're just showing you that it works even for those that you could factor. when you have something like this is not your final answer because 9 actually has a root. If that were square root of 7, you would actually be done here, okay? But you're not done because we have a perfect root here. So you actually need to do the 2 answers for this one. You need to say 5 plus the square root of 9, which is 3 over 2. And you need to say 5 minus the square root of 9, which is 3 over 2. 5 plus 3 over 2 is 4. 5 minus 3 over 2 is 1. And that is what x equals. Had you factored this guy, you would have done x minus 4, x minus 1, and you would have gotten those same answers, okay? Quadratic formula works for all quadratics. So this particular one is not factorable, all right, with integers. You could factor it with roots, but you're never going to think to do that. So again, it has to be equal to 0. And so you're going to move that 11 over. You do want it in standard form, so you want the 4x squared, the plus 12x, and then the minus 11, all right? And then we're just going to plug it in. This is my A, this is my B, this is my C. So negative B plus or minus the square root of B squared minus 4 times A times, that is a negative 11 there, by the way, times C all over 2 times A, all right? Then we're just doing order of operations. 12 squared is 144. We have 4 times 4 times 11, that's 16 times 11, which is 160 plus 16, so 176. It is plus because I have a negative times a negative. All right, so pay attention to your negatives here. All right, 176 all over 8. And then, of course, we have to add these. We get 320 over 8. Couple things I want to point out here. 320, if I want the exact, which is what I'm going to be asking for on these, then you have to do your factor tree. So you do need to do 320 and do your factoring here. All right, so factor it. Everything that pairs up can come out. So I have a 2 that can come out. I have another 2 that can come out, and I have another 2 that can come out, all right? If multiple things come out, you multiply them. I have a 5 that stays in. So this simplifies to 8 square root of 5. So I would write that negative 12 plus or minus 8 square root of 5 over 8. All right, how do I simplify this? Here's the thing. You can reduce this, but it has to come out of every number, every integer, okay? And you can only reduce outside to outside. So I cannot reduce, obviously 5 and 8 don't reduce anyway. But if this was a number that reduced with 8, I could not reduce the 8 and the 5. But to reduce the 8, I have to reduce it with the 12 and the 8 on top. So I have to have something that comes out of 12 and 8 and 8. And it reduces all of them, okay? Think of it as factoring out a common factor on top and reducing it with the bottom, all right? So what number comes out of 8, 8, and 12? 4. And so I can divide all of those by 4. I can divide 12 by 4. What do I get?
3.
Yeah, 8 by 4 and 8 by 4. And so my final answer here is negative 3 plus or minus 2 square root of 5 over 2. That is my answer. That is technically 2 answers. If they said round to the nearest, you would say negative 3 plus 2 square root of 5 divided by 2. Negative 3 minus 2 square root of 5 over 2. All right? But this would be your answer to what does x equal. All right? That is your answer to what does x equal. All right, so first rule, make sure it's equal to 0. This guy's equal to 0. And then we are going to just plug it in. Negative b. So negative 10 is just 10. Plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right. And then we're just going to do our order of operations. This ends up being 100. 4 times 29 is, we should subtract 116, I think. Yes. All right, all over 2. All right, so what happens here? Well, when I do this, I get 100 minus 116, which gives me negative 16 in my root. All right? This is an imaginary number. Now, 16 has a perfect root, which is nice. If it didn't, I would just simplify it like I did on the last ones and then take the I out. In this case, it has a perfect root, so this ends up being 10 plus or minus. My root of 16 is 4, and because it was negative, I have to put an I there, all over 2. Now, once again, with complex numbers, you do have to factor it out of everything. You can divide it out. So you could say, well, 10 over 2 plus or minus 4i over 2. That's one way to think about factoring these as well. Usually with the radical, you leave the numerator as a group and put it over the denominator. So that's why you reduce it all together. With complex numbers, you have a real part and an imaginary part. So you can reduce it this way if you want to. This one reduces out of your denominator altogether. So 10 divided by 2 gives you 5. Plus or minus 4 divided by 2 gives you 2i. That is your answer. You cannot combine the 5 and the 2i, so there is no way to give me a decimal approximation of this one. All right, you would just leave it 5 plus or minus 2i. Those are the two answers for what x equals.